So today I'll solve a question from functional analysis. So this is a question of GATE 2019. It's question number 12. Let x and y be non-linear spaces and t be this is a linear operator from x to y which is bijective and linear with the closed graph. Then which of the following statements is true? 4 options are given. So you have to check which one is true. Okay, so in order to solve this is the NPTEL reference. This you can look into it. Okay, so let's start solving the question. So what it is given that x, y are non-linear spaces, not necessarily Banach spaces, so they may not be complete. So it is saying that such that the linear operator has closed graph, but as the x and y are not necessarily Banach spaces, so we cannot use the closed graph theorem, because for closed graph theorem x, y we need to be Banach spaces. So first option is saying that the graph of t is equal to x cross y. So let's check that this is true or not. So option 1. So first we are given x and y non-linear spaces, and t is a map from x to y which is bijective and linear with closed graph. So closed graph means what is graph? Graph of a function. So graph of t is the tuple x comma tx, say that x belongs to capital X. So means this set is closed in the product topology in x cross y. So this is a subset of x cross y. T has closed graph. Mean the graph of T is closed in the product topology x cross y. Okay. So first option you have to check that the graph of t is equals to x cross y or not. So let's so what is saying the graph of t, the graph of t is equal to x cross y. So this is false. Why? Let's take this example. T defined from R to R, identity map T of x going to x. Then what is graph of T? So graph of T is x comma tx, say that x belongs to R. So this is x comma x. So this is the diagonal of R cross R. So this is a strict proper subset of R cross R. So this is not equals to R cross R. So the first option is false. Graph of t is not equals to x cross y. And the next option, option B, is saying that T inverse is continuous. So B T inverse is continuous. So first let's check why T inverse, because T is given to be bijective. As T is bijective, so T inverse exists. So this is again false, we will check. So if we are saying that this is not continuous, means we have to give a counter example. So let's take x to be the, so first define that L1 of n. So this is a sequence space such that the sequence is summable. Okay. So inside L1 we define, so let's take x to be x, and define the norm. And what is a sequence? If A is in L1, we define the norm of L1 norm of A is to be n equals to 1 to infinity mod n. Now define x. So what will take x to be the L1 with L1 norm. And we also define, and y we define another space. So this is L1 with different norm, L2 norm. What is L2 norm here? So this is square summable. So n mod square n equals to 1 to infinity to the power half. Now if a sequence is in L1, why the L2 norm will be finite? So that we need to check, right? So this you can check, that if means L2 norm is less than L1 norm. So just check this. A L2 norm is less than L1 norm. So as A we have taken from sequence from L1 space, so L1 norm is finite, so L2 norm is also finite. So this is well defined. Okay. So these two spaces are fine, x with L1 norm and y is L1 with L2 norm. Now we defined a linear operator, so you have to check that T inverse will not be continuous. So define T from x to y. This is again we are defining this to be identity map, T of x going to x. So this is obviously linear and bijective. So note T is linear and bijective. Again we have to also check that graph of T is closed. We have to check. So let's check that graph of T is closed. Graph of T is closed. So why the graph of t is closed? What is graph of t? X comma tx such that x is in x so closed means we have to check that if you take a sequence from here and converges to some point, then the limit point should be in this set. So means we have to check let xn converges to x in x and xn converges to y in y, then to show x equals to y. And xn converges to x means, so xn converges to x in L1 norm. So as xn converges to x in x imply xn converges to x in L1 norm. And xn converges to y in y imply xn converges to y in L2 norm. And as we have said that L2 norm is less than y, as we have L2 norm is less than L1 norm for all a in L1. So xn minus x L2 norm is less than xn minus x L1 norm. And as this converges to 0 in L1 means xn converges to x in all x2 also. So xn converges to x in L2 norm also. And as xn converges to both x and y in L2 norm, so by uniqueness of the limit, so by uniqueness of the limit, we get x equals to y. Okay, so means the graph of t is closed. So graph of t is closed. Okay. And this is as bijective, so inverse is well defined. Now you have to show that inverse is not continuous. Now we have to check T inverse is not continuous. So we will prove this by contradiction. So let us assume that suppose T inverse is continuous. So where is map? T inverse is a map from what to where? So T inverse is a map from y to x. It is continuous. Okay, then what is the, for linear operator, what is the definition of continuity? So means T inverse of A L1 norm is less than C times A L2 norm for all A in Y and for some C positive. Okay. So suppose this hold. So let us rewrite it again. So what is this? So L1 norm means, as T inverse is identity map, so A L1 norm, it is saying that let's C times A L2 norm. Means L1 norm should be less than C times n equals to 1 to infinity. So this should happen for all A in Y. Right. So we will show that this is not possible. So let's take this. So take FM, this sequence. So let's take this point first. Take 1 half 1 by 3 dot 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 1 by n and 0. So this is in Y, right? Because this is 0 after finite element term. So this is in finite with respect to L2 norm. So this is in Y. So put this in this equation. Putting this n star, we have summation n equals to 1 to n 1 by n should be less than C times summation n equals to 1 to n 1 by n square. Now we know that right hand side is finite because it is the summation 1 by n square, which is, and now take n tends to infinity. So this is true for any n. Note this is, oh, now we can vary n. Now if we vary n, now if we take n tends to infinity, then what will happen? Then the left hand side we know as summation n equals to 1 to infinity 1 by n diverges, but summation n equals to 1 to infinity 1 by n square convergent. So one cannot be true, so one cannot hold. So this is a contradiction, right? Because this cannot hold, because if you increase n, then the left hand side will become infinite, but right hand side is always finite. So one cannot hold means what we have. So this is contradiction. So why we get the contradiction? Because we have assumed that T inverse is continuous, means such inequality holds. So therefore T inverse is not continuous. Therefore T inverse is not continuous. Okay. So option 2 is again false. T inverse is not continuous. Now let's check the third option. The graph of T inverse is closed. Graph of T inverse is closed. So we'll show that this is true. So what is graph of T inverse? Graph of T inverse, this is y comma T inverse y. So this is y comma y cross x such that y belongs to capital Y. So to show graph is closed means we have to take two sequence. So let yn comma T inverse yn, this belongs to graph of T inverse such that yn comma T inverse yn converges to some point, let's say y comma x. So then to show y comma x belongs to graph of T inverse x. Which is same as the T inverse of y equals to x. Or this is because T is bijective, this is same as T of x equals to y. So this we have to show that T of x equals to y. And what we have assumed that yn, this we have assumed yn converges to this. So what is the meaning? So we have yn converges to y and T inverse yn converges to x. So let T inverse yn equals to x. xn means yn equals to T of xn. So T of xn converges to y and xn converges to x. Now but T is closed, but as graph of T is closed, so this is the definition of the closed graph, right? What is the definition of closed graph? If xn converges to x and txn converges to y, then T of x must be y. So T of x equals to y. So that we have to show, right? T of x equals to y. So therefore we are done. So graph of T inverse is closed. Okay. So we have shown that the graph of T inverse is closed. So this is true. Now what is the last option? The T is continuous. So again we show that this is not true. This is also not true. T is continuous. So as early, let's take again the same example. You recall example from notation from Option B. What was there? X is L1 with respect to L1 norm. Y was L1 with respect to L2 norm. Now here we will define, let's define. Here we will switch between x to y. So there we have defined t from x to y. Now we will define t from y to x. T from y to x. Again the same map, t of x equals to x, identity map. So we will show that t is not continuous. So again you can show that the graph of not t is linear and bijective. As option 2, option B, we can show. Means this is the same because there is also the identity map. You can show that this graph of t is also closed. So this operator satisfies the hypothesis of our problems. Now we have to check that the t may not be continuous. So this example t is not continuous, but it's satisfying the hypothesis. So t is not continuous. Now we will show that t is not continuous. So again we prove it by contradiction. So suppose t is continuous. Suppose t from y to x is continuous. Means what is this saying? Because y is with respect to the L2 now. So t of a, which is in x, so its L1 norm should be less than c times a L2 norm for some c positive and for all a in y. So this is same as, because t is identity, so t of a is a, so L1 norm is less than c times a L2 norm. But so this is again same as n equals to 1 to infinity an less than c times but as early, so this is same argument as we have seen earlier, that take this and then again, because this is the same thing we have to show that this can't happen, because if you take, then the left hand side will goes to infinity but right hand side is finite. So this is not true. So this is not true. As shown in option B. So this cannot hold. So t is not continuous. Okay. So what we have got? That graph of t is equals to x cross y, so this is false. T inverse is continuous, this is also false. Graph of T inverse is closed, so this is true. And T is continuous, so this is also false. So only option number C is the correct option. Okay.